Okay guys, welcome back. We're going to start off with more simplified schematics and troubleshooting, different meters, different things that we're looking for in testing and everything else. And then on Thursday, we'll get into the actual schematics of some machines and start talking about troubleshooting. Why do we make a test here? Why do we make a test there? Let's start off with a circuit. Let's talk about what makes up a circuit. All right, that's a wiring diagram for what?
Light bulb.
A light bulb, and what else do you see there?
Switch.
And a switch.
And a light bulb.
A rotor switch,
This would be what?
Line 1. Neutral.
Line 1, line 2. With the arrows on it, that would be a plug. You don't have to draw the arrows. Once you get used to wiring diagrams, you're going to start to see the same diagram look like this. The same thing without bringing it in. All right. In this diagram, how many wires am I using in this diagram?
I would say about 3.
About 3? About 6? 12?
We're referring to the one.
How many wires am I using?
3.
So, okay.
3.
We're using 3 wires. You got 1 wire coming into the switch, 1 wire between the switch and the light, and another wire from here out. Let me draw it as a pictorial wire diagram and show you the same thing so you can see that. First of all, we have a light bulb, and it's screwed in, and then you have a little filament inside. And in order to make a light bulb work, you have to have how many wires? 2 wires. So we're going to take 1 wire and stick it to the side of the light bulb. That's where the threads are inside your light bulb. And then we'll take another wire and put it right in the bottom in the center for a second wire. Okay? Now, if you look at the light bulb, we got 2 wires, so we're talking about the same 2 wires here. If we follow this wire back, it goes to what? What is this? What do you say the arrows were?
Plug.
It's a plug. So this thing runs back to, and we'll draw a little line like that with a plug. Now the other wire goes from where to where? Switch. So if I draw a simple switch, like a microwave switch, and it's got 2 terminals on it, 1, 2, one of those wires goes to the switch. Inside the switch it has a little contact, and this one goes where?
Back to the plug.
Back to the plug. So I got 1 wire from the plug to the switch, 1 wire between the plug and the switch and the light bulb, and another wire back. Can you see how those 2 circuits are identical but drawn differently? Okay, that's a start. Now, if I have a circuit like this, and the light bulb don't work, what kinds of, don't tell me where and so forth, what kinds of tests can we do to find the problem?
Voltage.
We can do voltage,
Ohms.
and we can do ohms. Which is better and why? Yes?
I prefer ohms because I can test each component.
Okay, you can test each component, but what if we have no power in the outlet? Will your ohm meter tell you have power in the outlet?
No.
No. So, different tests do different things. And this is part of the lecture, is to tell you why would we use one test over another, okay? Voltage is almost always the test of choice over resistance. The only time that we really want to go to resistance first is when we're testing something like a microwave that has 4,000 volts of electricity. We're testing a motor or other components that have moving parts like a belt or the motor's moving or a pump's moving, and to get your meter leads or the wires or your hands in that area to make a test, it's not safe. Okay? So let's talk about the different tests. I'm going to go ahead and we got a meter here. and I'm gonna draw an analog meter. And I'm gonna put 1 meter lead here and 1 meter lead here. If I do an ohms test, what am I actually testing? I'm testing the light bulb. So my meter is testing there to there. How does that meter work? I mean, what's making the meter work? Whether it's digital, or in this case it's analog with a needle, what's making it work?
The potential voltage in that light bulb.
Light bulb has no voltage.
Oh.
When we do ohms tests, we're not gonna plug it into the wall, will we? We'll damage our meter.
Yeah.
What?
Continuity.
Not continuity. Continuity is the test,
Resistance.
not resistance.
If a battery pushing voltage through it.
A battery. I just saw one over there, so. There's a battery in this meter. Right here. One side of this meter is positive, one side of this meter is negative. When you look at your meter, you got a plus and a minus. And that plus and minus on your meter may also be as a red meter lead or a black meter lead, but it's the battery, okay? This, when you connect this, goes through the needle. So as the current is going through, it's causing the needle to move. If the light bulb is broken here, does the power go through the bulb? No, so your meter don't register. That's when you're testing ohms. Okay? Let's take a look at in order to test volts, there's two things I need to do to this circuit. What are they?
Close the switch.
I have to close the switch, so I'm gonna put circles here and close it and plug it in, right? So now it has to be plugged in and we have to have voltage. How much voltage do most circuits have? that we deal with?
120?
120. We'll get into higher voltages in a minute. So you have 120 volts. When I'm making a test here, what reading should I have here if everything is working okay? Yes?
0.
Huh?
Zero.
0?
120.
120. If the switch is closed and it's plugged in, I should have 120 volts here. One side of this is we'll call what? What do we call this?
Line one.
Line 1, what do we call this?
Neutral.
Neutral. So line 1 feeds in to here, neutral feeds into here. Am I testing the light bulb right now?
No.
No. What am I testing?
The circuit.
I'm testing the circuit. So, in this unit, when I put my meter here and here, I'm testing the circuit. If this light bulb doesn't work, and I'm making this voltage test, what reading should I get if the light bulb don't work, but the problem is a bad light bulb? What reading should I get there?
120.
120. If I have 120 volts here, and the light bulb don't work, the bulb's bad. What if I test here and I don't have 120?
There's no power.
There's no power. So, before we go to a machine,
No.
let me finish. Before we go to a machine, and we find out the motor's not working, or the water valve's not letting water in, one of the first things we want to test is the outlet, right? To see if there's power there. We don't want to start taking panels off and just go, okay, my machine's filled with water and it's not draining, it won't do anything. I'm gonna go to the drain pump. Let me take the panel off, let me get down to the drain pump, let me see if I'm getting power to it. That's a good test, but my friend called me today, his washer wasn't working. LG washer. He says, my washer's not working. I said, well, he says, I think the lock switch is bad. I said, okay, why do you think the lock switch is bad? Does it light up? Does it give you anything on the display and the controls? He says, no, it don't even light up. I says, well, if the lock mechanism's bad, it'll probably light up. So I don't think it's a lock mechanism. I said, when you press it, you don't hear no noises, you don't see anything. He says, no, it's dead. I said, do me a favor. Check the outlet. And he didn't have a meter readily available. I said, get a drill, a lamp, plug it into the outlet and tell me if it works. He says, oh yeah, it works. So he got power there. I said, okay, plug the machine back in. He pressed the start button, the machine came on.
So it wasn't.
The plug might not have been in the outlet too good. You know, so one of the first tests you want to make is power at the wall to the machine before you start taking panels off and just start testing crazy things. Okay? But in this case, if this light bulb is not working and I don't have 120 volts, does it mean my bulb is bad?
No.
No. If I want to know if the bulb's good or bad, I go to ohms. But if I don't have voltage to my bulb, it's never going to light good or bad. So I have to find out why the voltage here is not getting down here. Okay? Could be the switch. Could be one of what? 3 what?
Wires.
Could be one of 3 wires. Okay? So how do we check a circuit? How do we test a circuit out? Yes.
Well, like, you already have your test around the light bulb, right? So wouldn't you work your way back and the points that has the most points?
Well, it's not necessarily the most points, but you would probably look at the most obvious things, like, well, if I have
Directly
power
below
in
the
the
switch.
outlet and I don't have power to the light, it's probably my switch. Probably. And I know 9 out of 10 guys will walk up and say, no, I got no power there, I'm gonna order you a switch, I'll be back with the switch on Tuesday. They don't even test it. Then they come back and they put the switch in, it still don't work. Now, wires don't just break on their own. They usually break because they're cut, they rub, they got heated up. You know, maybe they were undersized and they burned the wire or something like that.
That should go.
But what we need to do, similar to what Ross said, is something called backtracking. Okay? I'm gonna take this same circuit now and draw it with those straight lines on the next screen and explain something. So if I got this circuit here with a switch, and I'm gonna draw this as a light bulb. And I put my meter here. My first test to the light bulb is 0 volts. So I need that voltage to make that bulb work. What is the next test I need to make if I'm going to go from here back to line 1? What is the next test I'm going to
Other
make?
side of the switch, and the other side of the light
Here?
bulb.
Okay. So let's take this and move this over here. And your meter says 120 volts.
Yeah. Switch and then making contact.
Switch is bad, right?
Still haven't tested the cable. The wire in between.
This wire could be bad, right?
Yeah.
Well, did we miss something? I mean, we didn't have voltage here. We have voltage here.
Well, then we can move back over 1 point and make sure if it's a
Okay.
switch or not.
We go here. So we're not supposed to go from here all the way over here with this test. This is jumping too far back. Let me use it as an example of, let's say I gave you $20 and I said, listen, I need you to run over to Home Depot and get me a box of, drywall screws. We're gonna build something in class. So I give you the 20, you put it in your pocket. On the way over there, you stopped at Taco Bell, right? And then you went to Home Depot. Well, you get to Home Depot, you get the box of screws, you get in line, you reach in your pocket, the $20 bill's not there. So you could have lost it from here to Taco Bell to Home Depot, right? So you drive back to Taco Bell, nobody in the store, nobody found the $20. It's not there. Drive back to school, it's not there. So where is the $20?
In your car.
It might have fallen out in the car. So in other words, you're going to a whole test point, but you're missing something in between. Because maybe it fell out of your pocket while you were driving. Now, it could have fallen out when you left school to go to the Taco Bell, or you reached in your pocket to pay for the food at Taco Bell. Maybe it fell out in the car after you left Taco Bell. But when we do this test, if this wire was broke here, and I move this all the way over here, I'm gonna get 120 volts. But what that test is telling me is I have voltage to here and to here. But it's not checking whether it's the wire or the switch. So when we backtrack, we go from here, we go to here. If the wire's broken, what do I get?
Just 20 volts.
I get 120 because the voltage went through the switch. All right? So what you do when you're checking a circuit is you go to the load. This is the load. It could be a heating element, solenoid, light bulb, motor, and you say, do I have power to my load? If I have power to the load and the load don't work, problem's at my load. If I don't have power, I gotta find out how come I have it at the outlet, how come it didn't make it down there? There could be several switches in that line, could be several wires. So what you do is you go load, check the wire, check the switch, check the wire, and if I had 5 switches in a row, wire, switch, wire, switch, wire, switch, we go back until we find the problem. Okay, let's do a hypothetical. I'm gonna make a crazy diagram here. All those letters are test points for your meter.
Okay.
Okay? They're all different places you can put your meter to test. We really don't put our meter right in the middle. It's one end of the wire or the end of the other end of the wire. Okay? So if I put my meter on F and G, my light bulb's not working. Now I know the switches are drawn in the open position. Assume that all of them were manually closed. Okay? So here are the readings that you got with your meter. Wait till I'm done. Give everybody a chance to try to figure it out before you answer, and let's see if you can figure it out. F and G gave you 0 volts, okay? F and H, 0 volts. F and I, 0 volts. F and J, 0 volts. Now, let's try E and G, 0. D and G, 0, C and G, 0, B and G, oops, 120, and A and G, 120. Take a minute based on all those readings. That means you put a meter on F, and you put a meter on G, and your meter didn't give you a voltage reading. One by one, look at those readings. Take a minute before you get an answer.
Just
Take a
wanted to.
minute. Yes.
It's about you said right after the D and G. Is that a C and
C and
G?
G.
Or is it C and G?
Oh, that's a G, sorry. My blue and black are, okay. Ross knows the answer. Anybody else? Julia knows the answer. Darla knows the answer. Ross had his hand up first. Do the rest of you guys have an idea?
Wait.
Wait, come on. It should take you only a minute. You something should see it. Ross, what's your answer?
Switch B and C.
Good.
Switch B and C. And how do you determine that?
Well, because from B to G, I've got 120 volts, but from C to G, I
Okay.
have 0 voltage.
So when you check B to G here, you had 120 volts, correct? But when you check from C to G,
I got
you
0.
had 0. So you had voltage up to this point,
Mm-hmm.
but when your meter lead was here and here, you didn't have any voltage.
Which means it's not coming across the switch.
What can you tell me about the neutral circuit in this?
It's good up until C.
I'm sorry?
You mean
It's good up until C.
Not, well, this is not the neutral circuit, this is all
G.
line one, yes,
The neutral side is 0 if it has no voltage going to that side.
no,
the neutral side is completing the circuit if you're getting 120 because it's not gonna, if it's not making connection, you're not gonna get a reading.
okay, so that means, I think what you're saying is that this neutral here
Reaches the
is good all the way back.
Right.
Yes, because you weren't getting power.
And here, my voltage went to this, but it never made it to that one.
Exactly, so it wasn't completing the
See,
circuit.
when we're checking voltage versus ohms, when I check ohms, I'm checking between my 2 meters, whatever I'm touching. I'm not checking out into the machine. But I'm checking voltage, I'm not checking between my meters, I'm checking the circuit outside back to the plug. Because I'm trying to get that power from the plug down to that light bulb. Follow me? Okay. This one's gonna be a little bit trickier because I'm not gonna give you just a cut in A to G, B to G, C to G, D to G. It's not gonna be like that. Let's see if we can do another one. But that didn't work.
I'm trying to do it fast enough.
Let me erase this so it's not confusing. Hold on, hold on. You already got your answer. Give everybody else a chance. I'll give Julian a chance. But you guys, it's all over the place now, right? It's a little harder this way because when you are working on a machine, those wires aren't in a straight line. They're drawn on paper that way. They go all over the place inside the machine. These are just test points, and you need to know, if I said touch C and touch E, you have to know where that point C is and where that point E is to put your meter to make that test. Okay? Let's still look. I'll take some time. Give you some time to figure it out. Tomorrow you'll have a paper with some of this practice to do on your own. I'll also put it on the website. When I upload the video, I'll put a downloadable page for you to practice, and then Thursday I'll go over the answers. During my lecture, I'll go over the answers from the page, and then we'll go into an actual machine diagram. Hold on, Pedro. Julian had his hand up first, so I'm gonna give him the first opportunity. Yes,
This count or not?
that's just a wire.
I mean, the blue. The blue one.
No, the blue was from
I
before.
want to bring it out to him.
Julian, what do you think is wrong?
Okay, first off, I think there's a bit of an error because D and H has been repeated twice. The page
Oh,
one,
it is,
you know.
it is an error.
Yeah.
So which one is the correct one?
Yeah.
Well, let's get rid of this one.
That's what I was
It
trying.
shouldn't be one. Right.
Okay.
Right. Now
Alright.
we're talking. Now we're talking.
That's what I was
So-
using my head for.
What's happening is that if from E to I, you're getting 120 volts. That means that obviously voltage is reaching past those two switches to the right
To the
and
left?
No, well, to my left. Wow. Oh my God. I got that on camera. All right. So
Don't worry. We know you're
we'll edit that out. All
Okay,
right.
so, no, I'll
Oh.
emphasize that.
Yeah.
Julian messed it up.
Okay, so
Okay.
from the left-hand side, the voltage has passed those two switches, and from the right, we're testing the point before, well, after the H to I switch. So we're getting to 120 from there. But once we actually put our leads right on the H, which would be before the switch actually connects to neutral, that's when we get no voltage whatsoever.
You're right, but you confused the heck out of me.
Yeah, I know. I probably won't.
So let me explain it in layman's terms. So first voltage reading I have is E to I. So let me draw that circuit E to I. So I go from here to E
Right,
and from here to I.
right.
That means I have voltage up to that point. So anything from here back is good. Because if anything was broken here, I won't have voltage. I don't know if this wire is good. I don't know if this bulb is good. I don't know if this wire is good, or I don't know if this switch is good, because this stops right here and this stops right here. So remember, my test goes back to the plug and it goes back two different ways. I'm testing two different ways at the same time, okay? So I still have 1, 2, 3, 4 things that could be wrong. So if I want, I could go F to G, and F to G says 0, so the voltage didn't make it here. So my light bulb could still be bad because I didn't test the bulb, but I'm not getting voltage to it. So now I've sort of eliminated one of those 4 things, right? Because I'm not getting voltage to the bulb, we have to still figure out why am I not getting voltage to the bulb. So we take the bulb out of the circuit, we have 2 wires and a switch. If we look at D and H, that is 0. Well, according to E, I have voltage up to here, so does that mean I have voltage at D?
Yeah.
Okay, and this one is H. Well, when I check from here to here, I have 0 volts. So I have voltage to I, but I don't have voltage to what? H. So what's my
Switch
problem?
it back.
The switch is bad. So when you're in a machine, if you jump all over the place with both meter leads, it gets a little confusing. It took some of you a little bit longer to come up with the answer, especially if you're not used to doing this. So when you look at this diagram, we want to take the circuit, and wherever the load again is motor, heating element, solenoid, anything that really does something in the machine. That's what we're trying to get power to. You got to remember that if we take a look at machines and take a look at loads, let's take a few appliances, let's talk about them, and then I'll get back to this diagram for a second. Name me all the major loads in just a basic dryer, nothing crazy. Give me the loads.
Board.
Not even a board, let's just say mechanical.
Is it mechanical stuff?
You got a motor,
The motor, the heater,
heater,
the
and a timer motor.
Belt switch?
It's not a load, a belt switch.
is a switch.
Yeah, you're right.
A switch is called a control. So you got a motor, a heating element, and the timer has a motor. That's it. 3 main parts in a dryer. That's it. But there's a lot of wires, right? Why all these wires for 3 little parts? Because the controls, which are the switches and everything else, we have more than one control controlling the heater. We have more than one control controlling the motor. We have more than one control controlling the timer. Okay? We'll talk about these circuits on Thursday, but the point is, everything else in the machine is the wires and the controls to send power to one of those 3 loads. Let's do a simple, basic Whirlpool direct drive washer. What are the loads in a direct drive washer? You got a motor,
Inlet valves.
the water valve, and a timer. That's it. 3 electrical parts. Everything else, lid switch, pressure switch, water temperature switch, timer switches. They're just all controls sending power to those parts. And you're like, when you walk up to a machine, you see all these wires everywhere. And you're looking at it and you're scratching your head like, I don't know where to begin. I don't know if I check here or if I check this wire, or I check that wire. You have to know each one of these parts. Because let's take a dryer, for example. I'm going to come back to that diagram for a second. We got a dryer, okay? We got line 1, we got neutral, we got line 2. Okay. 3 loads. Heating element, drive motor, centrifugal switch here. You know what? Let me draw the centrifugal switch a little bit differently. Does anybody know what that is?
Pressure switch.
Push to start switch. What switch is that? Centrifugal. What switch is that? I put the letter to help you out. Starts with what?
Door switch.
Door switch. Okay, here's my motor. Anybody know what that piece is? That's the thermal fuse on the back of the dryer. What's that? Timer switch. So that's the motor circuit. Alright? We got a timer switch for the heater, right? Thermal cutoff. It's a fuse. Thermal fuse, thermal cutoff. This is more like a whirlpool dryer diagram, by the way. And so then we have this. Which one is
High
that?
limit thermostat.
Operating thermostat. In the whirlpool diagrams, the high limit is always right next to the heater. So we got an operating, high limit, thermal cutoff, timer, heater. Is that heater circuit complete? Those of you guys that have completed dryers, do I have everything that's in that circuit drawn?
Not always.
What, Joey?
Usually by the line 2, there would be a switch there, which I'm assuming would be from the motor. You know what I'm
more
talking about.
details, you're in the right part.
Oh, okay. Well, I didn't know I was gonna go this far.
What?
So,
It goes to the centrifugal switch on the motor.